And good afternoon, everyone. Welcome to another Gretel workshop. It is August 10th, 2022, coming to you live from the wonderful area of, well, we'll say Austin, Texas. I'm within that area. Um, it's hot. It's hot and dry. But we are here to talk today about synthetic data and do a quick introduction to synthetic data. So I'm going to give it about a minute or so, just kind of chatting here to let everyone kind of join in, and then we're going to go ahead and get started. So a quick run of show for today is I'm going to basically do a PowerPoint presentation, kind of a presentation that I present. This is a typical presentation that I give at conferences whenever I'm talking about synthetic data. This is an introduction to synthetic data. So if you've never heard of synthetic data before, you're in the right place. This is a great place to be right now. And we're going to start at the beginning and we're going to go from there. So hopefully you're ready and you want to learn about that. And then after that, we're going to do some demos. So just demo a couple of the Gretel products, doing some base synthetic data generation, doing a kind of tabular style data generation, and then doing some text generation with GPT, which is going to be really fun. And then after that, I will answer any questions that you have in chat. So if you have any questions, please drop them in the chat. I will be able to bring them up and view them on screen, and then we can go from there. If you're tuning in from YouTube, while you're here, go ahead and hit the subscribe button. That really does help us out, and we'll let you know when we go live again, because we're doing these Gretel workshops and Gretel deep dives, basically Gretel live events, every second and fourth Wednesday of the month, with some mild adjustments for holidays and such. Okay, so, and if you want to hear anything else more about us, that was a weird sentence. If you want to hear anything more about us, please follow us on Twitter. That's where you'll find a lot more announcements about all the cool things that we're doing. So let's go ahead and get started. It's about 2.5 minutes past the beginning. So we pull up my screen here, and we're going to talk about synthetic data and what that means. So the title of this talk is "I Can't Believe It's Not Real Data: An Introduction to Synthetic Data." It's a pun for those of you that live in the United States. Yeah, I can't believe it's not real butter. It's a funny little pun. I enjoy it. It makes me laugh. That's what matters. My name is Mason Egger, and I am the lead developer advocate here at Gretel. Here to talk to you today about synthetic data. So let's go ahead and get started. So I like to always frame things in the mind of, like, if you were actually like trying to look for this as a solution, like what would you be looking for? So imagine that you're a developer working on a web application. I'm a Python person, so we'll say Django. Django is my favorite Python web framework. It is what it is. And we're working on a application that manages students in a classroom. Basic, grades, attendance, seating charts, things like that. And now it's time to test. It's time to test our application and see what's going on. Or is it going to be good? Is it going to be bad? What's broken? Where are we not broken? And we go to test, but we can't access the production database for security reasons. For anyone that works in education knows that FERPA data is protected by law, and it's a little bit difficult to get your access on it. So you won't be allowed to have access to it anyway. So you have to use a test database with only a handful of records. Maybe this is a test database that you've made yourself, but it doesn't really account for all the edge cases. Instead of it having, hundreds of thousands of student data or even tens of thousands, it has like 3 because you couldn't be bothered to create a lot of test data, which, that happens. Developers really don't like to spend a lot of time on testing, so they don't really worry about their test data as much. So, you're working with this minimal data set, and an edge case slips through that wasn't represented in the test database. So had you had access to the production database, maybe you would have found this edge case, but because you didn't have access to prod-like data and you weren't able to account for everything, and an edge case slipped through, and now there's an error. That error could be as minor as, the web page crashes, could be as major as now people can change their grades. Who knows what that error is, but either way, you were unable to account for it because you didn't have the proper data that you needed. Now imagine also, let's go away from another standpoint. Instead of being a developer, that you're a data scientist and you're trying to build some sort of model or something to predict, some event. Let's go ahead and say, for the sake of this discussion, you're working at like a hospital or a healthcare institution, and you want to try to predict a rare disease. So you start looking for relevant data sets, but you find out that you really don't have enough of the data that you need. There's just not enough patient data on, the presentation of this rare disease. So you really can't go forward with it, but you kind of want to, because, anything's better than nothing, you think. And so you end up training the model on the limited data set. And unfortunately, the model is just unsuccessful. It doesn't have a high percentage rate of predicting the rare disease, just because the size of the data was not, it was not adequate enough to get you there. Sweet. And then, so, it just didn't work. And then, but wait, someone from another area, from another hospital, maybe someone from another medical institution down the road has a similar data set. They have also collected data on this rare disease. And if you combine these two together, now you'll have enough data and you can actually train your model properly. But that plan immediately gets just like shut down, because you can't access that data, because that data contains PII, and there's all these rules about releasing patient data or obfuscating patient data, or just making patient data private so people can't access it. So you had a glimmer of hope, and then it kind of shortly just got dashed away from you, because it just wasn't accessible. So these are very common. I kind of highlighted, as you saw in bold, 3 very common data challenges, and we're going to talk about those more in depth in a little bit. But just common data challenges that a lot of developers, data scientists, people like that make are the access of usable testing data. There was a study done, and that's what this chart is showing, that 35% of data scientists' time is spent in the data gathering stage. So, you want to build these models, you want to do all this fun stuff, but in reality, most of the time that is being spent, you're spending in the part that you probably don't want to be spending it in, which is going around and collecting the data. Data can be inaccessible due to the PII, as we saw in our second example there with the healthcare information. Limited data sets there's just not, maybe your data set is lacking. Lack of quality data can affect model training results. If you just don't have good data, or you just don't have data at all, you don't have any access to it, it's probably going to affect your results. Thus it's prohibitively expensive, or even sometimes impossible, to collect more of this data. Maybe that this is, you were collecting data on, I don't know, maybe an asteroid going through the sky that orbits Earth, or goes through the sky once every 300 years. It is actually almost impossible, unless you wait 300 years, to collect more data on that specific event. I think maybe like Halley's Comet is like every 70 years. So if you miss it, you really don't have the opportunity to collect more data. And then there's also biased data. So let's also just talk about the elephant in the room, that not only, even if we do have data, sometimes that data is biased and can be skewed towards representation of subjects. It can skew the representation, in ways that we don't want, ways that are not good for anyone, and they can lead to some really awkward problems or some really bad situations. So we have all of these issues, just access to usable testing data, the limited data sets, and biased data. So what do we do about this? Well, synthetic data is kind of the solution to these problems. A good definition, I like to always start with a definition. This comes from our chief product officer about what synthetic data is. And synthetic data is artificially annotated information that is generated by computer algorithms or simulations, commonly used as an alternative to real-world data. Now, that's kind of a mouthful. So let's talk about it. Let's say it in maybe a more broad sense. Synthetic data is data that is generated based on looking at a data set that you already have and creating more data like it that is statistically equivalent. That's all it is. There's no more fancy words. You're just creating more data that looks like the original data set that you have, at least in this definition. Maybe there's other definitions. Who knows? But for now, what we're going to talk about, that's the use case we're talking about. And then whenever you hear that, the first thing you may think is like, well, isn't that just fake data? And that's the first question I had whenever I first heard about synthetic data. So that was my reaction. I can understand why it would be yours too. It's not, though. Synthetic data is very different from fake or mock data. If you work with Python or something, you may be thinking of the Faker library. Fake or mock data is not representative. It's purely random. You've given it a schema of things. Maybe you've given it a schema of addresses. This is the number of the street, the county, the zip code and stuff. But those can be completely fake and maybe not even be relevant to you whatsoever. It also just comes in looking too clean. every field is perfect. There's no garbage in your data. Like, when have you ever worked with data and there wasn't junk in it? So fake or mock data is not representative, and it's just not what real data looks like. So you're training on something that's not what the data looks like, or you're testing against something that's not what the data originally would look like. But then when you go from there and then you want to go, why does my application not work? Well, because that's not what it's actually going to be expecting. You need to be providing it with inputs that it would actually expect from the real world. So synthetic data is generated from the existing data. It will look and behave like the initial data set. Like this data is generated through multiple different means and will look and be representative statistically of the data set that you originally fed into it. So it's a great way to be able to test on data that you may not be able to have access to, or get someone to get you a synthetic data set of a production database. So anyway, we're going to talk about that a little bit more in depth here in a second. So let's talk about the benefits of synthetic data. There's a lot of benefits of synthetic data. Today, I'm going to talk about 3 that are important to me, or the top 3 that I like talking about. So number 1, making private data accessible and safely shareable. Number 2, generating more samples with limited data sets. And number 3, reducing bias in machine learning data sets. These are what I call the big three promises of synthetic data right now. So let's talk about the first one, make private data accessible and shareable. So very often, data will contain PII, or what's known as personally identifiable information, making it very risky, or in some cases, illegal for developers to even work or touch with or look at. And the reality of this is that developers and data scientists don't want access to this data. They really don't. Like, they don't want access to PII. They want access to the correlations that the data has. They could care less if the name, maybe you have records with a name, they could care less whose name it is, as long as the other data helps them test their case. So you don't want that. They don't want access to this. Generating a synthetic data set allows you to have statistically similar data while removing the PII. And this will allow you to share your data, not only within the company, but externally as well. So imagine you're trying to test and you need access to the production database, but no one can be given access to the prod database because we can't just hand out keys to the prod database and let everyone have access to it. There's PII in it. They could potentially cause some damage to the database, and which would bring down the application. It's not good. Or on the other set, you have a data set that you want to train a model on, but it's at another hospital, like we said. Well, if we can remove all that PII, then we can share it internally to developers. So if you're looking for a prod database, you can just develop on it. Or if you're, training a data science set and it's at another hospital, now they can share it with you, and there's no worry of the data, the PI, the personally identifiable information leaking out. So now we can share stuff. Just imagine what we could do if everyone could share all their data. Think of all the different models and things that we could train if that was accessible. And that's one of the big promises of synthetic data. The second one, augmenting small data sets. So not having enough of the right data is a serious bottleneck. So as we saw in another example, they didn't have enough data, so they couldn't properly train the model. And this is a very common thing, is that more often than not, you just don't have enough data. Unless you're a very large corporation that has these large data ingestion pipelines, it's very difficult to gather and get enough data to do what you need to do. Data is very often the most valuable asset that companies can get a hold of. Data is, that's why all these data privacy laws are going into effect, because of how valuable data is on people. And collecting data is expensive and hard. It's not easy. You have to do a lot of stuff to collect data. So synthetic data allows you to generate an unlimited amount of data based on a relatively small data set. So if you have a small data set, maybe let's say 1,000 records, and you need something to be up to 10,000 records, you can take that synthetic data set and then generate 9,000 more records, or as many as you want, of that data set. And now you have more. Now you have that 10,000 or 1,000,000. Who knows? Maybe you need more. Now, a common question with this is, well, what if that data set originally was skewered? Like, what if that original 1,000 was completely unrepresentative or full of bias? Will the synthetic data carry along those traits? And the answer is yes, it will. It's whatever you put in is what you're going to get out. So if that data set is just woefully flawed, it will remain woefully flawed. Synthetic data cannot magically fix a data set and make it not flawed and not biased in that sense. There are tricks, and we're going to talk about it, where you can intervene with synthetic data to do this. But like just setting it in and going, boom, we collected all this data from this part of town and we actually want, all of it. No, it didn't work. So that's not something that like you're going to get in kind of what you put out, but you can tweak that. We're going to talk about that a little bit later. But it will help if that data set is representative, you'll be able to generate as much as you want. And the thing is, maybe you don't know if that data set is representative, so you generate more and then you can figure it out. The thing here is that you can generate as much of this data as you want now, and then you can do your work and then evaluate the results. And now you can do that evaluation and figure out, is that what you actually wanted? This is especially prevalent in the public sector, where poor data format practices, storing stuff in PDFs, cause for an abundance of inaccessible data. So not having enough data. That's also very prevalent in small tech startups, because they just don't have the data ingestion pipelines, the data collection pipelines that they need to get that to work. So it's really good to be able to generate more data. And then from there, you can determine what, the efficacy of your data is still on you to determine. But now you can, have a lot more of it that you can then be able to get a clear answer on the efficacy of it. Number 3, one of my favorite ones, reducing bias in data sets. So I said earlier that synthetic data can't completely remove bias. And that's like automatically, it can't magically figure out, hey, this is biased and it's wrong. But you can, and then you can use synthetic data to augment things to make it where it works. So biased data is a big problem. It leads to inaccurate models, it leads to unfair results, and it may even, in some instances, cause harm. Like, we don't want it to, but you can look online, you'll see tons of stories around, AI and harm, and it's just, it's nasty. So we have to account for bias. The thing is, though, is if you can identify the bias on your data set, like if you can look at that data set and say that data set is biased, well, now you have a new tool to help fix that. So you can use synthetic data to balance your data set. There's a really great case study that we've done here at Gretel on reducing AI bias with synthetic data in heart disease prediction models. I believe this model comes from this data set model comes from Kaggle. And essentially what had happened is that 68% of the data was male and 32% of the data was female. Why that happened, anyone knows, but that was just what it was. So there was a 2-to-1 ratio of the data being more accurate or more skewed towards male patients than female patients. We were able to see this and then augment the data set to create more female records and balance the data set more to a 50-50% correlation. Or sorry, 50-50%, I can't think of the word for that, balance. It increased the accuracy of the model when we did this from 88.5% to 96.6%. 6.17% more females with heart disease can now be accurately diagnosed. And a really interesting thing is that the accuracy for predicting male data also went up. Because when you have the more balanced your data set is, the more likely your model is to actually learn and not guess, which is what I've heard. I hope that makes sense. But so that's a great thing, is not only were we able to augment it, remove the bias, and increase the outcome for females, we were also able to increase the outcome for male data as well, because maybe the biases were affecting the way the model was trained. So yes, can send that data auto-magically detect and remove bias? No. But if you can do it, it's a great tool to help you balance your data sets, and then you can go from there. And if it doesn't work, this is the great thing about synthetic data. If you spend you're not going to, like when I say you spend all that time balancing, if you spend like 5-10 minutes running the code to balance it and it doesn't work, try something else. Now you have access to as much data and as many formats formats that you want. So try it. Now you basically get to do, the advantage of software engineering is that, like, versus say bridge building, is that I can test my software, and more likely than not, testing my software doesn't hurt anybody. Now, if I'm just testing bridges and I'm like, well, I think if I build this bridge this way, it'll be fine, and then the bridge collapses and hurts people, you don't really get that opportunity. In software engineering, there's almost no negative impact to testing. And now we're moving this into the data science space, where now data scientists have different ways they can tweak their data and get the best results out of it. And there's not that many consequences of it. Say if you were the bridge builder that said, I wonder if breadsticks will hold up a bridge, and then the bridge collapses and you're like, breadsticks didn't work. You don't get that. You get that in software engineering, and now hopefully data science. So another really good question that a lot of people ask is synthetic data accurate? Well, unlike fake data, synthetic data is nearly as accurate as the real data. And in some cases, as demonstrated in this blog post, the accuracy is improved. So, one of the things that we've noticed and that we've done is that when we augment a training set with synthetic data, the mean machine learning accuracy has a less than 1% deviation from the real world equivalent. So, the data is, in fact, very accurate and like alongside of it. Now, you can generate synthetic data that is inaccurate, but Gretel has a synthetic data quality score, which shows you all of the cool things you can do with it. And we're going to go into that a little bit later in the demo. Talking about quality of synthetic data, it's a fun one. Current challenges in synthetic data. So I'm over here telling you that this thing can solve everything, and it's fantastic, and it is. I love it. It's actually really cool. But like obviously there has to be some downsides. Like not everything can be the best thing on the face of the planet. Then you're right. Highly dimensional data sets with hundreds or thousands of columns can be very compute intensive. So this is still very difficult to generate whenever the data set gets large because it can be compute intensive. It's not impossible. It just might run up your AWS bill. Or if you're using us, however much you're paying for it. Synthesizing relational databases can require some manual configuration, keeping the relationships there. So might have to do some tweaking there. Some privacy-preserving technologies, such as differential privacy, require large amounts of data to provide strong privacy guarantees without degrading accuracy, and this may not be appropriate for all data sets. And then synthetic data generation requires time and effort. Like this is still, you're training a model on your data to generate more of it. That does take time. The more complex it is, and maybe the first time you generate it, it's not the best. You may have to tweak and modify a couple things to figure out, hey, this is actually the best data for me. So it does take time and effort. It's not just automagical. We would like to get it there, maybe in the future. But this is like cool, like synthetic data, like this is brand new tech. Is it already being used somewhere in like industry and stuff? And the answer actually is yes. Synthetic data is being used in a lot of places. It's being used in automotive and robotics, leveraging synthetic data to create simulated environments for training robots. Self-driving cars is a big one, and even testing safety and crash prevention. Financial services, helping protect customers' privacy, crypto, cybersecurity, and InfoSec, helping detect fraud and cyber attacks, healthcare and life sciences, creating synthetic genomic data, which is something that we're working on, like synthesizing a human genome. Just like think about that for a second. It's probably one of the most complicated things in the universe, and synthesizing it, making fake genomes. That still boggles my mind, and it's so cool to talk about. Manufacturing, using synthetic data to simulate complex supply chain operations and predict when they may fail. So many people ask me about this, and it's not like when I first joined, this was not the use case that I thought that people were going to ask me about, but it's one that people ask me about, so I put it in here. You can use it to generate time series data that basically is representative of the sensors, so you can try to predict when sensors are going to fail, or like just have more data. Like if the sensor only sends out an error message every 3 years, you can augment a synthetic data set and create more of those error messages, which would be really fun. And there's so many more. This is like a small list of so many different places that are using synthetic data. So what does the future hold for synthetic data? Well, by 2030, Gartner predicts that synthetic data will overshadow real data AI and models. And we're already starting to see that happening. But as more and more synthetic data is out there, we will, or more and more tools are created to create it. Eventually, real data will be the seed for synthetic data, and models will be trained on synthetic data. That's what we're already kind of seeing today. This allows for much easier compliance under data protection laws such as GDPR and CCPA. It also reduces the attack vector on data. So like now your data is safer when you're training it. And like we're always looking for ways to make data privacy and data stuff safer. So how do we get started using synthetic data? It sounds so cool. Well, there's a lot of resources available. There's this open source agenda list that has a whole tags of it. We have a awesome synthetic data repository where we list all the really cool things, and we're constantly updating that about synthetic data. Gretel makes it easy, which is really awesome. All of our models are open source, so if you want to see what we're doing or train the model yourself, you can. There are no code options available. You can run it in our cloud or on-prem, depending on what your data governance model requires. So let's talk a little bit about Gretel. And we did this a little bit backwards. So it's based on open source models. You can go to our GitHub repository and check out these models right now if you want. If you don't have a GPU and you just want to try it out, because remember, training models will probably require some of this, just try out our free tier. We have a really awesome free tier at, just go to console.gretel.ai or just gretel.ai's website, and you will be able to find it and train it. Or sorry, create an account and then start training data really quickly. There are many ways to run. We have a dashboard, CLI, SDK, Python, REST API. But today we're going to talk about the Python SDK. So let's go ahead and get into the demo. And then we go over here. Okay, so whenever I log into my Gretel account, this is basically what I'm given. It has a key. I don't have any projects yet because I usually delete them before I demo. You can send out invites to people. This is the dashboard. But yeah, you basically grab this key. And then we're going to go over here to this. We're going to reconnect this Jupyter Collab notebook. So you would need to install. Let's zoom in a little bit so you can see a little bit better. This Gretel client and pandas. So Gretel client pandas is a really, and it keeps doing that, but it's fine. Gretel client is our Python SDK, and pandas is pandas. We're going to import this code, these things. So we're going to configure session, read model config. We're going to pull creator grid. I'll explain these as we get down. So basically, configure session is how you log in. And basically, it gives you a prompt in the notebook where you can just provide your API key. And then the API key will basically, allow you to be logged in, and there you go. And now it's cached too, so you don't have to keep doing that over and over again. So the next thing we're going to do is we're going to create a project. So a project is what we would see here. And we're going to either create a project or get a unique project. So if there's a project named Synthetic Demo, we're going to get it. And if there's not, then we're going to create it. Then we're going to read this model config. This is the default config. This is very well documented in our documentation, but there is a happy path config, but then there's also a lot of tweakable items you can also change that we'll talk about here in a second. So this project will create it. And if we go back to our Gretel dashboard, we will see the Synthetic Demo project is now here. And we haven't done anything with it yet, but we have created the project. And then this is the configuration. So a lot of these are we're going to do 100 epochs. We're going to, what else do we have here? Batch size of 64, the maximum invalid, the number of records we want to generate. So we're going to generate 5,000 records. We can easily change this, but all of these are basically hyperparameter tunings. So for each model, you can figure out which ones you can tune, and then you can help tune to that as well. Validators, all that stuff. And then we have this data set right here. This is the U.S. Adult Income 5K, which is a data set that is income data and education data. And then basically, I think it is help to you use it to predict based on a certain set 5 or 6, maybe more factors, what the income is going to be above or below 50,000. So we'll just go ahead and import that directly from S3, read it into a CSV, and read the CSV and put it into a data frame in pandas. Then create our own CSV here that we're going to be submitting up to Gretel. And then we'll do a df.head so you can see the age of this person is 42. What sector do they work in? I don't know what that is. their education number, I guess how much they've done, marital status, occupation, just a whole bunch of stuff. So this data here, what their capital gains are, income bracket, all that jazz. So what we do is we come down from here, and now we're going to create a model object based off of the config and then off of the data source that we've created. And then we're going to create that model object in our project, save it to model, and then we're going to submit it to the cloud, which is our Gretel cloud. And then we're going to pull it and just see what happens. And basically what the poll is going to do is it's going to track the training of the model. And then from there, it's also going to let us know when it's done and maybe give us some sample data at the end. So if anyone has any questions, now is a great time, because we're going to literally sit here and watch a model train. If not, what we'll do is we'll work on another model in tandem, because there's 2 examples that I'm giving today. Let me check. I think I might have some questions from some people. Yes. So I guess while we're here, let's talk about some other resources that you can use while we're waiting on this model to train. So there are a couple of really good additional resources you can use. Docs.Gretel AI is the Gretel documentation. Gretel blueprints are a really good data source that we have. Those are for those are pre-written out basically notebooks on how to solve certain problems. So we'll look at that. And then there's also another repository called Fun with Synthetic Data, which is the second model that I'm going to train and we'll talk about. But let's look at the Gretel blueprints. This is Gretel Synthetics. So we want to go back to Gretel AI's GitHub repository and we'll go to Gretel blueprints right here. So Gretel blueprints are just a whole GitHub repository filled with data sets on how to accomplish certain things with Gretel. So we can balance data with conditional data generation. The heart disease one that I was telling you about, balance UCI heart disease. This is the notebook that we did it with. So the heart training data, we were able to basically generate and precede how many we wanted to, what we wanted to prepare the object to specify the conditional data generation task. Yeah, all that fun stuff. So if you're looking for like how do we discover PII, which is another thing that Gretel can do, or how do we create synthetic data from a data frame, or how do I create synthetic data from time series data, you can come to these Gretel blueprints and they have tons of information and just ready to go working code that you can use to get going. We're still waiting on this to train. So let's talk about fun with synthetic data while we're waiting on that to train. So actually first, let's also talk about this. This is Gretel Synthetics. So this is the open source library. You can literally go to github.com/GretelAI/Gretel-synthetics, and you can view the source for our open source, so time series stuff. You can view the source code for our Gretel synthetic library. We also have a GPT one that's based off of the OpenAI GPT model that we're going to do here in a second. Do some text generation by generating sample test lyrics. But yeah, so this is Gretel Synthetics. It's still going. I think we just did a lot of epochs, so that's going to make it take a while, which is fine. While we're also here, let's go ahead and talk about fun with synthetic data. The fun with synthetic data is a cool little repository, and you'll be able to look at the lyric generator one that we're about to do here in a second. And these are basically just fun things you can do with synthetic data. So this one is Gretel Bartender, and it generates cocktail recipes based on by training the model on real cocktail recipes. So synthetic cocktail recipes. Lyric generator generates lyrics based on lyrics that we're going to get from like various artists like Taylor Swift and Dua Lipa and all that. So still waiting on you. Let's go ahead and work on this one, and then we'll go back to no, I don't want more disk space. Please go away. Please go away. Thank you. So lyric generator, you're going to see the code looks almost identical. And that's actually one of the things that's one of the benefits you get from Gretel is that the SDK, only thing that really changes for the model is the config. So you get like this common interface for different models for training synthetic data, which is very nice. So let's go ahead and log in. We have to grab our Gretel API key again. So let's go back to Gretel, do a copy right here. We're going to go ahead and grab that. So as you can see, this code looks pretty much the same. We're still logging in. We're creating the new project. We're going to manually specify the config here because the Gretel GPTX GPT is a little bit different. It's basically the Eleuther AI GPT Neo implementation with 125 million records. What we're going to do for the batch size and all of that. We're going to do a really quick batch of one with one epoch. So that's the configuration that we would send. Now with GPT, it's a little bit different because GPT takes a single column. So if you look at our data that we have, which I should have done a better job of, but like the data is like artist, title, album, year, date, lyric, the clean lyrics, because we removed some of the naughty words because some of these people say some naughty things. And then what we do from there is we basically create this data set. So what we're going to do is we're going to combine that, and we're going to create a combined column over here. And okay, this is what happens when your mouse, and it's also only going to truncate at 256 characters. If you let it keep going on and on, it will definitely use a lot more memory and stuff. And also 256 characters, first couple lines of it, maybe getting to the chorus, it's more than enough to be able to train stuff. So we have that. So let's go ahead and click here and let's train the synthetic data model for this GPT model. So as you can see, it's still basically the same thing. We have our source, we have a name, we give the model config, and then we submit it to the cloud. I mean, the only thing we did different here is instead of adding this as a parameter in this, we set it as like an instance variable right here. So we're basically just waiting on all of this to create. Let's go back and check. It looks like the synthetic demo one is done. It has generated the record. So let's go ahead and spit out like the first 5, like df-head or df.head, the synthetic data frame head. So we see the age, the work class here, something with some question marks, but private, some college, married, never married, only child, race, gender, all of that, income bracket, capital gains, capital losses, hours per week that they work. And if we scroll back up, whoop, come on. I always scroll in the wrong part of the notebook. That's like my curse. We scroll back up, it looks, relatively identical. Like you would not be able to tell the difference between this data, and this data. So yeah, we did some cool stuff with that. Occupation. And that is synthetic data generation for Gretel synthetics, the LSTM, so what we call long short-term memory, but basically that is tabular data generation. Now the fun one over here that I like is doing the GPT generation. And we're waiting on it. Now, one question that some people might have is like, will all the data that synthetics generates be perfect? And the answer to that is not necessarily. You may still need to look at, you need to look at the quality of your data. So let's do that now while we're waiting on this. I completely forgot we were going to talk about synthetic data quality. So if we go to our project, Gretel produces what we call a quality report. And it gives us a synthetic data quality score. And we test these things by doing field correlation stability, deep structure stability, and field distribution stability. We talked about this a lot in our previous deep dive that we did literally last week. So if you want, go check out that YouTube video, and you can learn a lot more about it. But what we're going to do is we're going to download the synthetic data report, and we're going to go ahead and open it up. So it downloads an HTML file. And then the cool thing about this synthetic data report is like whenever you click on all these bubbles, it will tell you everything you want to know about this. Like this is probably one of the most detailed reports I've ever seen in tech, and I love it because it just tells me everything that I need to know. So the row count, the column count, there's some privacy protection things that we could do here. We don't have differential privacy. This tells us the distribution stability, capital gain, capital loss, the education. So it looks like it's good. We have a base score of 88. Deep structure stability of 85, and then we have all of these. So like we can even so basically like if these pictures look the same, what's the difference between the data correlation here? And you can even do like little lines where you can see like what does it look like and where do they overlap. So basically the training correlations is the original data, the synthetic correlations is the synthetic data, and this heat map over here is the correlation and how far it's drifted. And the lighter the color, the more accurate it is. So if you look up here, like this one's a little bit dark, but like most of this is relatively light. And then the principal component analysis, if these graphs look relatively similar, then that's a good way of going about it. Do we have we can discuss? I think if you click up here, the field correlation we'll talk about. One of these talks about the principal. Yeah, right here, principal component analysis. And we'll explain a lot more of it. So yeah, these will tell you the field distribution comparisons, like how much have they changed, and a whole bunch of stuff. But as you can see, like we have a very in-depth report that tells you about like how we measure this, how confident we are that this data is representative of your original data set, which over here we have an 88, and 88 is good. It's great. If you go watch that deep dive from last week, it's actually really interesting. Is that I know a lot of us have like this desire, like perfect, and we have to be perfect, and so we want to get to like 100, and that's actually not a good thing here, because then you would almost think that the data sets, like you get a little bit weary about it. It's like this little bit of noise helps with the privacy. If it was like purely like identical, then I would kind of be worried about the privacy. So like as Amy and Lipka spoke about last week, 88 is a fantastic score. They've like been able to see amazing results on data that's trained that is even like in the 60 and stuff in the good level. So yeah, there was another one that I feel like I'm missing a part of it, but maybe it was in a blog that I'm looking for. Kind of tells you like what this is good for. So a score of like in this excellent range is totally fine for training like models on and such, and then like even in like down into the good stuff, like all great for testing. So our lyric generator is done. So we're going to generate some synthetic lyrics. So let's just generate random lyrics off the top of our head. Let's not seed the model in any way. Let's just say, hey, produce me some lyrics, which we're going to do right here. And it actually goes back and generates the lyrics from the cloud. Anything more about that? I could talk about this synthetic data report forever. It's so fascinating. Yeah, the data's all pretty. It's got nice little drop downs to help teach you stuff, which I love. Oopsie. Oh, this is the thing I was looking for. So yeah, so whenever you click on the synthetic quality score, it says the synthetic quality score is an estimate of how well the generated synthetic data maintains the same statistical properties as the original data set. In this sense, the synthetic data quality score can be viewed as a utility score of confidence or confidence score as to whether scientific conclusions drawn from the synthetic data set would be the same if you were to have used the original data set instead. If you do not require statistical symmetry, as might be the case for testing or a demo environment, a lower score may just be as acceptable. And that's where we talk about here, like we talk about like what is this, like demo environments or mock data. Moderate score here works fine. Improve your model using our tips and advice. You can go all the way down to poor. You'll need to significantly tune it if it comes up to very poor. But like machine learning and statistical analysis, if you get a score of excellent or good, it totally means that you could get away with using this data, and that's pretty awesome. So this is the fun one because it always generates some fancy stuff. Looks like it's got a whole bunch of new line characters. Mother's still alive. Song lyrics are actually very difficult to generate because it's interesting stuff. But okay, here's an interesting one. I've heard stories about the people I love and the people I care about and the people I have come to love and cares. Okay, that's gets a little degrades a little bit there at the end. I'm a real lady and I live a different life. That is the life I live for a million miles. And I would walk 500 miles. Yeah. Anyway, don't ask me to sing anymore for you. But yeah, so this is like just telling us, hey, what'd you get? But we can actually precede this data. And let's say we did this last time. So Taylor Swift, we prompt it with Happy Duck. So the prompt is, what is the title? The title is, who is the artist? So we can look and say, basically generate songs in the style of Taylor Swift with some happy ducks. The title of the song is going to be called Happy Ducks. And we're going to say Bilbo was a happy duck who. And then we're just going to run this and we're going to see what we get from it. So this is actually where we'll get like by actually like prompting the GPT model, we'll get much better results than just like saying, hey, GPT, what are you thinking? A prompt of nothing. Computers. Asking computer what it's thinking with no prompt. Definitely not an easy thing to do. So we're going to let this run a little bit. If there's any questions in the chat, please feel free to drop them. I haven't had any come through yet. If you just want to say hi, I'll say hi to you. I'll pull you up on screen and say hi. I mean, like your little message, not you. I won't make you come live and come chat with me, but come say hi. Okay, looks like we're good here. And if we scroll down and we say, Bilbo was a happy duck who would do the duck at the end of a lifetime, wasn't happy to have no joy, who would have had enough of his troubles and had grown tired of everything and is now happier with his feet, was born in a happy place, and you gave a happy duck, and yeah. So some of these are a little bit nonsensical. That's really interesting because the longer it seems that you let this go, the more it seems to devolve a little bit. But this is valid text. Like these somewhat make some sense. Had enough of his troubles and had grown tired of everything and is now happier with his feet out and his mouth open, looking down at his reflection. I mean, like, yeah, like that almost kind of sounds like Taylor Swift. I'm not going to tell you these are going to win an Emmy a Grammy. Emmy is daytime TV, I think, or TV, I think. I don't know. I'm not an expert in that. But yeah, we've generated human-like data. Again, I'm not going to tell you this is going to win any sort of awards as being the best songwriting of the century. But if you do happen to use synthetic data to generate an award-winning song, please let us know. We would at least like a picture of the Grammy. So T Swift, if you're listening, have at it. But yeah, so that's generating, seeding the model to generate stuff. You can do a lot more with it. A good example of like this lyric generator is a little bit fun, but if you come look at, where do I have it at? I think I have it in my personal, let me open up a thing real quick, my Google Drive. If we compare the GPT model one to this chatbot one. So generating lyrics, you're probably not going to do that for your day job. That's probably something you're going to do for fun. But this chatbot text synthesizer, as you look, is the exact same code. Like legitimately, it is the exact same code. I copy and pasted it. I changed this data set path, and I changed this what it combines the data sets into. So like a call and a response. As you can see, this code is the exact same down to the wire, and then it generates synthetic data for conversations. So the what we prompt this is, how are you today? I'm doing fine, thank you. I'm going to the movies this weekend. I'm serious. You'll get to see it in theaters. Why not? I was missing you a little earlier. You're missing me too. I'll call you later. How are you going to make it? I'll start at the store tomorrow. Like, this is real text. Like, these are real sentences. It may not be the most coherent of situations, but it's real, and this is what we did. And it's the same code. It's the same exact code. We changed the data path and we changed the pre-data tweaking, and we got the exact same thing, which is fascinating. And that's the advantage that you get with Gretel, is you get the common experience of the SDK, of the CLI, of the console. And the other cool thing, while we're here, I've got a couple more minutes left. Let's talk about this synthetic demo one, the synthetic data one we did. We can come in here and say I want another 10,000 records or 1,000 records or however many records. Now that I've trained that model, then I can give people access to this. They can come in and just generate as many models off that train, any records off that trained model as they want. So now, like the default here, not the default, the data model that we've trained here, now we can just generate as much as we want from the console whenever we want. So the console experience is also really cool. Okay, I think that's enough of the demo. There's a few things left. So let's talk about this. So free swag. Everyone wants some swag. I know it. If you would like some swag, you can go to grtl.ai. That's our bit.ly short link. And do /workshop/intro. Or you can scan this QR code. It'll take you to the Google form. Give us your email, your mailing address, and we'll make sure that we can actually ship it to you. We're not going to do anything with your data. We promise. We're a data privacy company. We're not going to sell your data. And then we're going to, tell us if you want to hear more about Gretel, and we'll send you some swag. If you've been watching this and you've watched prior live streams, you'll know that we've said that a lot, and it's almost done. We're this close to being able to send out the swag. So if you do this one today and this is your first one, you should be getting it, a lot sooner than other people. We finally got the swag going through the pipeline. So that's all the time I have for today. If you enjoyed listening to me, or you want to hear more from me, or you have any questions that you didn't put in the chat, feel free to just follow me on Twitter at Mason Egger. You can also join the Gretel Slack channel. And we will, it's our Gretel community, and we're happy to talk to you. grtl.ai/Slack. So like Gretel.ai, the full spell out is our full URL, and grtl.ai is our bit.ly link. You can also follow us on Twitter at Gretel_AI if you want to learn more from us or learn more about what we're doing. The slides are currently on my website. And the other thing to talk about is that this free swag I will leave this Google form open for a week. So on August 17th around noonish, we'll stop taking responses to this. So if you want some swag, please fill it out. We'll happily send it to you. If you filled it out before, fill it out again. We'd love to hear from you again. You may get different swag. Ooh. But yes, thank you so much for attending. Be sure to follow us on Twitter, and if you're watching us from YouTube or LinkedIn, follow us on YouTube, subscribe, and ring the little bell. That'll let you know when we go live. We're going to be doing a lot more of these developer workshops, deep dives, founder AMAs, just a lot of fun stuff here on the YouTube channel as we build out Gretel, as we build out the synthetic data community. Thank you so much for your time today. I hope you got something out of this. Again, feel free to tweet at me if you have any questions. Have a great day, everyone, and I hope you have a great rest of your week. Bye-bye.